In this lecture, we are going to be talking about the chemistry of life. I'm going to expect you to know certain things about the chemistry of what makes us us. I'm not going to go into a lot of detail. That will be for when you get to chemistry next year. But I do expect you to be aware and to know certain parts of chemistry in order to be able to talk about stuff that's going to come down the road in the future. We got to start. When we're talking about chemistry, we got to start at the very beginning, and that's going to be with atoms. Atoms are the smallest unit of matter. It's the tiniest thing that makes up matter. It's the building blocks of everything in our world. With atoms, you have 3 parts to every atom. They're called the 3 subatomic particles. First particle that I want you to know is known as the neutron. A lot of times in class, I will abbreviate this as N with a little O above it. That little symbol tells you everything you need to know about the neutron. If you just look at the word neutron, neutral, then you know exactly what it is. This subatomic particle does not carry a charge. It is neutral. The second particle that I want you to know is called the proton. In class, instead of writing out proton, I will usually write it with P and a plus sign, kind of like a little exponent. That tells me everything I need to know about the proton. Protons carry a positive charge. Third subatomic particle is the counterbalance to the proton, and it is known as the electron. And I will usually talk about it as e to the negative kind of exponent. An electron balances out the protons, meaning electrons carry a negative charge. In class, we'll talk about this in terms of an actual model of an atom. So for now, just be familiar with proton, neutron, and electron, the 3 individual parts of an atom. And then we'll talk a little bit more in class about the rest of it. What atoms eventually form are called elements. Elements are defined as a pure substance made entirely of one type of atom. They are organized on the periodic table. When you get to chemistry, you'll go into a lot more depth than this. Within the periodic table, they are arranged, all elements are arranged by their atomic number. The atomic number, is based on the number of protons. Last thing I want you to know about the periodic table, all elements on the periodic table are represented by 1 or 2 letter symbols. So for example, if I wanted to wrap all this up on the periodic table, let's look at one of the most common elements on the periodic table, nitrogen. Nitrogen, its symbol is N. Its atomic number is 7. There are certain elements that I will require you to know the symbols, and we'll talk about those when we get to class. Now, life isn't always that easy. So in class, I'm going to talk about something we call an isotope. Next thing I want to talk about are molecules and compounds. These things, molecules, are when 2 or more atoms chemically combine. Compounds are a molecule that contains at least 2 different elements. The way I want you to think about this as you process what a molecule and a compound is, think about this statement, and I'll talk about it in class. All compounds are molecules, but not all molecules are compounds. And there's an S on there if you can see it. And this is where I want you to think, what do I mean? Think of the two different definitions and come up with some idea of what I mean. I want to continue talking about compounds for just a minute because I'm going to talk about them in terms of a chemical reaction. Whether we're talking about a molecule or a compound, they have to be chemically combined. And a chemical reaction is talked about in terms of chemical formulas. So one chemical formula that's pretty easy, that you guys are really familiar with, if I took hydrogen and I reacted it with oxygen, I would eventually make water. Now, in a chemical reaction, I've got to be able to balance my chemical reaction. So what that means is my hydrogen's got to be equal on both sides, my oxygens have to be equal on both sides. Looking at this, on the left side, your reactant side, so these are your reactants. My oxygens, I have 2 of them, but on my product side, which is always the right side, I only have 1 oxygen. So I got to balance those out, and I do that by adding a big number in front of the whole chemical formula for water. But when I do that, that messes with the number of hydrogens I have. Before I did that, I had 2 hydrogens on the left and 2 hydrogens on the right. Now that I added a 2 in front of H2O, now I have 4 hydrogens. You multiply things out. So I have to go back and I got to adjust my hydrogens on the reactant side. Now I have 4 hydrogens, 2 oxygens, and 2 oxygens. So everybody's happy. A chemical formula and a chemical reaction, I want you to think about it in a very specific way. If I wanted to make chocolate chip cookies, I follow a recipe. Well, a chemical reaction and a chemical formula, these two things, think of them as a recipe. It's a recipe to make something chemically. Now, in a chemical reaction, you've got several different things going on. When I make a compound, I have to chemically combine 2 things together. So say I wanted to hook 2 atoms together, and let's just do salt. Salt is NaCl. NaCl. Sodium has 1 extra electron on it, whereas chlorine has 7 going around it. Chlorine needs 1 more to make itself happy. And this is called an electron dot diagram, and I'll try to talk about this more in class. What happens when these 2 form NaCl, when they make the compound NaCl, sodium will give up its loner electron to chlorine in order to make it happy. Magic number is 8. When this happens, when an element gives up one of its electrons to another element, we call this an ionic bond. Just as a definition, 1 or more electrons are transferred from one atom to another. They are given up. This is one type of chemical bond that can form when I try to make a molecule or a compound. The other main type of chemical bond that we're going to talk about. Say I wanted to make water. Water has an oxygen and 2 hydrogens, H2O. Hydrogen, they each have 1 electron between them. Oxygen has 6. What happens? Hydrogen, if it gives up its electron in order to make an ionic bond, it has no electrons left. Hydrogen doesn't like that. Hydrogen will be happy with just 2 electrons. Oxygen needs 2 more to make the magic number of 8. It has 6, it needs 2 more. So what happens in this next type of chemical bond is we have sharing of electrons. Oxygen and hydrogen, between both hydrogens, will share electrons to make each one of them happy. When you have sharing, we call that covalent bond. Simply, electrons are shared between 2 atoms. They're not given up, they're not transferred, they are shared between two atoms. And these are called covalent bonds. Both of the bonds I just talked about, ionic and covalent, are bonds between atoms. So they are kind of atomic bonds. What also can happen, and I'm going to touch on this just very briefly, you can also have bonds between molecules. When you have this, it is called molecular attraction. These are bonds, and I'm going to put that in quotations because they're bonds, but they're not bonds, and I will explain that in class. Bonds between molecules / compounds. The premise behind this is pretty simple, and I'm going to use water as the main example of what it is. So I have a water molecule that has 2 hydrogens attached to it. Now, oxygen, because of its what we call electronegativity, it is stronger. It's kind of, I always describe it to my chemistry kids as the bully. It's going to pick on hydrogen, who is the weakest kid in the neighborhood. And what it's going to do, the electrons that are shared between oxygen and hydrogen, the oxygen is going to hog them more. And because they're electrons, and because they'll stay on oxygen a little bit longer because it's stronger and it's kind of the bully, oxygen takes on a slightly negative charge, which means on both of my hydrogens, I now become slightly positively charged. So if I have another water molecule nearby with the same setup, with positive and negatives, I can get an attraction just like opposites attract. I can get an attraction between the hydrogen of one atom and the oxygen of another atom. When this happens, and in this case it's a very specific type of molecular attraction, we call this a hydrogen bond. In order for something to be a hydrogen bond, it's got to be an attraction between hydrogen, obviously, and then it's very specific on what other molecules are with it. 2 of the most common ones are oxygen and nitrogen. Those are the 2 I'm going to require you to know. Oxygen and nitrogen. If it's oxygen and hydrogen or nitrogen and hydrogen, then you would form a hydrogen bond between atoms. If it does not fall into that category, it's not an oxygen-hydrogen bond or a nitrogen-hydrogen bond, we call it something completely different. Still works the same way, but it doesn't fall into the category of having oxygen and hydrogen or nitrogen and hydrogen working together. Anything outside of that, we call it van der Waals. So if it does not belong here, if it doesn't go with a hydrogen bond, then we call it a van der Waals. And I will give you some examples when we get into class. Since I'm still talking about water, the hydrogen bonds that form between water molecule give it a lot of very unique properties. One of the properties I would like you to know is cohesion. This is when you have an attraction between molecules of the same substance. So for example, the way I would demonstrate this one, think back to the activity I made you do a couple of classes ago, where I had you come up with a lab for water and a penny. Say I had my nice little penny, and you were dropping drops on there. What water will do is it will form a dome. So there is this connection. The hydrogen bonds are keeping all of those water molecules together until there's just too many, and then it will spill over and it'll cause your dome to break. That's what cohesion is. When there's an attraction between the molecules, and it creates, in the case of water, that dome you would see on top of the penny. So that's one of the traits that comes from a hydrogen bond. The other type of trait that I want you to know is adhesion. And you'll see this one a lot when we do labs. This one is the attraction between molecules of different substances. Now, I say you'll see this one a lot in lab because it's exactly what happens when you have to measure out, say, water in a graduated cylinder. You've got your graduated cylinder, and you've got to fill up some water. You got to put some water in there. And they always tell you where to measure the water. If you looked at it, that's what your water would look like. And anybody, any science teacher will always tell you, you got to measure from the bottom. How much water do you have at the bottom of the meniscus? You don't want to look at these areas. This is adhesion. The water molecules are clinging to the glass or the plastic of the graduated cylinder, and it's causing them to raise. But it's not the actual amount of water that's in there. They just have an attraction to that glass or to that plastic, and it's causing them to climb up the side of the graduated cylinder. So that's why it does that. The other example that I can give you for adhesion is known as capillary action. And this is how plants draw water from the roots to leaves. And I'm running out of room. Because when it rains, all that water filters through the soil and it collects down at the roots. Well, then the plant has to find some way to get that water from the roots up into the leaves. It's got to go through the stem, go out through the stem, or out through the stems of the leaves, and then into the leaves themselves. They need water. So the way it works is water will actually kind of climb up the roots and the stems to the leaves, out to the leaves, by what is called capillary action. And that's just another example of adhesion, where water will actually climb up a substance in order to get to where it needs to go. Last thing I want to go over with, and I will conclude this lecture, is what a mixture is. And hopefully you're like, oh gosh, why is she doing this? Gotta go through it. Mixtures, or a mixture, is composed of two or more substances that are physically combined. Whenever you think of a mixture, think of a salad. That's my best example for you. Think of a salad. You can pick out every single thing you put in that salad. On my salads, give me a thing of lettuce. Make sure there's mushrooms on there. Maybe some chopped up egg. Definitely some cheese. Some carrots. Some broccoli. Maybe some cauliflower. I don't know. I like a hodgepodge. But if I wanted to, I could go through and I could pick everything out of that salad and divide it back out to its original bits. So a mixture is always something that is physically combined together. They are not chemically combined, they are physically combined. That concludes your introductory lecture for the chemistry section. I will fill in blanks. I will answer questions when you get to class.